Okay, welcome back to another video. I hope this isn't an issue, but one of the reasons I haven't been consistently making videos, I believe, is because having to have the camera on, I just feel camera shy. I have to sit in like a specific way. If I'm on camera, I have to make sure, I don't have a bag of spinach in my teeth. So it's like I'm just gonna have the camera off. Hopefully that's not a problem. It might make it worse if I'm like in the middle of explaining something I can't do like hand gestures. Maybe that might worsen it. But the main thing I want is to just keep going on this and get this done as soon as I can. So having the camera on is just an impediment. All right, so we're gonna keep going here. This is system initialization. The good news is I do have my home lab now, though I'm doing this uh, so that I have access to my home lab, which I will bring up and then I will start reading. Okay, so I'm in my home lab. Let's start the reading. System initialization. Apart from the kernel, the operating system depends on other components that provide the expected features. Many of these components are loaded during the system initialization process, varying from simple shell scripts to more complex service programs. Scripts are often used to perform short-lived tasks that will run and terminate during the system initialization process. Services, also known as daemons, may be active all the time as they can be responsible for intrinsic aspects of the operating system. The diversity of ways that startup scripts and daemons, I call them daemons. I don't know how they're pronounced. Let me actually see how they're pronounced. Uh,
Demon.
oh, it is a demon. It is a demon. I don't know why I call them daemons. Um, but you know what? I might. Yeah, it's an archaic spelling of demon, and it's
Demon.
pronounced demon. I'm gonna pronounce them demons going forward. I don't know why I would call them daemons. Just because it looks like the name Damien, I guess. So like I pronounce them similar to how I pronounce a person named Damien. So like that's a bad reason. I think it's meant to be pronounced demon. Okay. I'll just start over again. Apart from the kernel, the operating system depends on other components that provide expected features. Many of these components are loaded during the system initialization process, varying from simple shell scripts to more complex service programs. Scripts are often used to perform short-lived tasks that will run and terminate during the system initialization process. Services, also known as daemons, may be active all the time as they can be responsible for intrinsic aspects of the operating system. The diversity of ways that startup scripts and daemons with the most different characteristics can be built into a Linux distribution is huge, a fact that historically hindered the development of a single solution that meets the expectations of maintainers and users of all Linux distributions. However, any tool that the distribution maintainers have chosen to perform this function will be able to start, stop, and restart system services. These actions are often performed by the system itself after a software update, for example, but the system administrator will almost always need to manually restart the service after making modifications to its configuration file. It is also convenient for a system administrator to be able to activate a particular set of daemons Depending on the circumstances, it should be possible, for example, to run just a minimum set of services in order to perform system maintenance tasks. All right, note. Strictly speaking, the operating system is just the kernel and its components, which control the hardware and manages all processes. It is common, however, to use the term operating system more loosely to designate an entire group of distinct programs that make up the software environment where the user can perform the basic computational tasks. Um, Okay, I'm gonna finish this section and then I want to interact with ChatGPT. The initialization of the operating system starts when the bootloader loads the kernel into RAM. Then the kernel will take charge of the CPU and will start to detect and set up the fundamental aspects of the operating system, like basic hardware configuration and memory addressing. The kernel will then open the init RAM FS, initial RAM file system. So that looks clear. INIT RAM FS, initial RAM file system. Easy to see what that stands for. The initial RAM file system is an archive containing a file system used as a temporary root file system during the boot process. The main purpose of an initial RAM file system file is to provide the required modules so the kernel can access the real root file system of the operating system. As soon as the root file system is available, the kernel will mount all file systems configured in /etc/ file system fstab file system fstab, and then we'll execute the first program, a utility named INIT. The init program is responsible for running all initialization scripts and system daemons. There are distinct implementations of such system initiators apart from the traditional init, like systemd and upstart. Since the init program is loaded, the init initial RAM file system is removed from RAM. All right, so here are the uh, um, I okay. I guess I'm not sure what we're talking about down here. Um, oh, okay, yeah. So here's systemd, here's upstart. So we're talking about distinct implementations of system initiators apart from the traditional. Oh, no, no, no. Okay, we're gonna go over the traditional um, init program or the programs that are a part of yeah, traditional initiation scripts and system daemons. So the first one we got here is sysv standard, and this is a service manager based on the sysvinit standard controls, which daemons and resources will be available by employing the concept of run levels. Run levels are numbered 0 through 26 and are designed by the distribution maintainers to fulfill specific purposes. The only run level definitions shared between all distributions are the run levels 0, 1, and 6. So if you're using Debian, if you're using Ubuntu, if you're using Mint, different distributions of Linux, you're going to have run levels 0, 1, and 6, but all the other run levels will not necessarily mean the same thing. Systemd is a modern system and services manager with a compatibility layer for the sysd commands. I want to check my, okay, looking good here. For the sysd commands and run levels, systemd has a concurrent structure, employs sockets and dbus for service activation, on-demand daemon execution, process monitoring with C groups, snapshot support, system session recovery, mount point control, and a dependency-based service control. In recent years, most major Linux distributions have gradually adopted systemd as their default system manager. Next one is Upstart. Like systemd, Upstart is a substitute to init. The focus of Upstart is to speed up the boot process by parallelizing the loading process of system services. Upstart was used by Ubuntu-based distributions in past releases, but today gave way to systemd. Okay, so here's the next section. Before I do that, I I am curious about this. So in Linux, how is pronounced?
Demons in the context of Linux is pronounced demons, which sounds similar to demons. This term is borrowed from Greek mythology, where demon is used to refer to a kind of spirit or divine power. In computing, a daemon is a background process that is designed to perform specific tasks, often in response to certain events or conditions.
Okay, are there other ways?
While the pronunciation demons is most commonly accepted, there can be some regional or personal variations in how demons is pronounced. Some people might pronounce it demons, rhyming with Raymonds. These variations can be influenced by accent, local dialect, or personal preference. However, the most technically accurate pronunciation is still demons.
All right, that's good to know. Okay, so moving on, initialization inspection. Errors may occur during the boot process, but they may not be so critical to completely halt the operating system. Notwithstanding, these errors may compromise the expected behavior of the system. All errors result in messages that can be used for future investigations, as they contain valuable information about when and how the error occurred. When no error messages are generated, the information collected during the boot process can be useful for tuning and configuration purposes. The memory space where the kernel stores its messages, including the boot messages, is called the kernel ring buffer. These messages are kept in the kernel ring buffer even when they are not displayed during the initialization process, like when an animation is displayed instead. Let me read that one more time. The memory state where the kernel stores its messages, including the boot messages, is called the kernel ring buffer. This is the memory space where the kernel stores its messages, including the boot messages. The messages are kept in the kernel ring buffer even when they are not displayed during the initialization process, like when an animation is displayed instead. Okay, so these are messages. It's storing boot messages. So like, let's think of it this way. So in Linux, when you boot up Linux, let me do this. Let me do this. Uh, Linux boot up. So like, yeah, like all this. Anyone who's using Linux, you see all these messages that come up. Now what's happening here is it's displaying the kernel ring buffer, right? Yeah, so it's displaying the kernel ring buffer. So like, you don't have to have this. Like, you can display other things besides all the messages in the kernel ring buffer. Um, but if you do so, that's just what's displayed on the screen. Like the messages will still be in the memory space. Um, yeah. However, the kernel ring buffer loses all messages when the system is turned off or by executing the command dmesg-clear. Without options, command dmesg displays the current messages in the kernel ring buffer. So these are all the messages associated with when the um, associated with the initialization process. All right, let's take a look at how this looks in my lab. And specifically, let's look for the run level, if we can see anything written about the run level. All right, I don't see anything yet. So the first message we got was the Linux version. Then we got a path to the boot image. And we notice here RO, so read only. So that must be um, well, assuming that's what that means. Um, okay, then we've got information about the CPUs. Looks like the BIOS provided some stuff. So the run level stuff should come after it's uh like after on in the process. One thing I'm trying to do is think of the boot up process. Now this uses a BIOS, so it'll be the boot up process that's associated with architectures that use BIOS instead of UEFI. So this should correspond to that process, these messages. Okay, so run levels, if there's anything about that, should probably be like near the end. All right, well, I don't see anything about that. One thing I can always do is pipe grep, and I'll just do run. Oh, pipe grep run. Okay, so now we've got runtime. We've got, oh, volume was not properly mounted. That could be a problem. Um, oh, okay. I'm not sure what's going there. So that's kind of a problem. Okay, and then yeah. So let's do it with so it's not case sensitive. Okay, we got the same thing. So I don't say anything about the run level. That's fine. That's probably as expected. I did see a lot of systemd messages. All right, moving on. The output of dmesg can be hundreds of lines long. Let's see how long my output was. Oh, WC. So mine was actually over 1,000 lines long. So the previous listing contains only the excerpt showing the kernel calling the systemd. Oh, hold on a second. There's this happened before. Sorry, I'm getting this uh, notification in my headset, and last time this happened, my headset just randomly stopped working. So I don't know if it's a low battery or what's going on, but I'm gonna pause it and I'll come back once I have this figured out. All right, I'm back. That unusual sound that I'm not used to hearing was another call, which this is multi-point Bluetooth, so uh, it's Bluetooth. It just nothing works ever. Okay, but this seems to be working. I trust this that I'm seeing here. I trust that at my own peril, perhaps. So, and I'm recording. So let's get back on topic to what we were doing before. We were looking at the output of DMESG on my home lab. We saw we have 1,000 lines of output. We tried to see if it corresponded to like the BIOS boot up process. Um, and now we're moving on to completing more of the reading. All right, so the next part is the output of DMESG can be hundreds of lines long. So the previous listing contains only the excerpt showing the kernel calling the systemd service manager. The values in the beginning of the lines are the amount of seconds relative to when kernel load begins. In systems based on systemd, command journalctl will show the initialization messages with options -b or -boot, -k or -dmesg. Command journalctl -list-boots shows a list of boot messages, or shows a list of boot numbers relative to the current boot, their identification hash, and the timestamps of the first and last corresponding messages. All right, so let's take a look at that on my home lab. Journalctl list boots. So here they've got 5 boots stored. Oh, I've got quite a few. I've got 20. That must be the max that it can store. Previous initialization logs are also kept in systems based on systemd, so messages from prior operating system sessions can still be inspected. If options -b0 or -boot equals 0 are provided, then messages for the current boot will be shown. Options -b -1 or -boot equals -1 will show messages from the previous initialization. Options -b -2 or -b equals -2, -boot equals -2 will show the messages from the initializations before that, and so on. The following excerpt shows the kernel calling the systemd service manager for the last initialization process. All right, so let's follow along, but we're going to look at more than just that. So let's start by looking at that. CTL-B0. And let's take a look at the first 5 messages here. So we've got the timestamp for when the logs begin. So it looks like my server, the last time, so it began there and ended there. Wow, okay. I'm kind of surprised about that. Let's see what that timestamp looks like for the -1. So this is the boot prior to that. Oh, that's interesting. Okay, I would have expected this end to be correlated with that, but it looks like they're the same there. Oh, this is just like telling me uh, for how long I've been logging total, and then this is not necessarily um, throughout this whole range. It just corresponds to the messages associated with the most recent boot. So that happened on June 12th, which um, is not a surprise. I remember unplugging it and plugging it back in. Okay, but prior to that, June 7th was the last time I did that. Let's see when I would have booted it before that. Yeah, this makes sense to me. February 23rd. So before June, I hadn't booted that thing. I left it plugged in for like 4 months. All right, so initialization and other messages issued by the operating system are stored in files inside the directory -var-log. So let's take a look at the files in that directory. There we go, all sorts of stuff. There's anyone familiar with Junipers, which this channel basically was all about Junipers. Um, there's like a slash messages file in Juniper. And there's like an interactive commands file as well. It looks like those commands aren't on here. This is a different distro. Juniper is based on FreeBSD. This is Ubuntu. So maybe there's things that are similar, but I don't see it named the same way. We do have this interesting one here called syslog. So let's see what's in there. Oh, let's see. Oh, I'm in the wrong present working directory. Yeah, because I listed it out without changing it to it. So I have to change to it. Let's take a look at the fail log. I don't want to spend that much time on this when I'm so close to finishing the reading. Okay, nothing in the fail log. That's good. Initialization and other messages issued by the operating system are stored in files inside the directory /var/log. If a critical error happens and the operating system is unable to continue the initialization process after loading the kernel and the initial RAM file system, an alternative boot medium could be used to start the system and to access the corresponding file system. Then the files under -var-log or // can be searched for possible reasons causing the interruption of the boot process. Options -d or -- directory of command journal CTL can be used to read log messages in directories other than /var, /log, /journal, which is the default location for systemd log messages. As systemd's log messages are not stored in raw text, the command journal CTL is required to read them. Okay, so let's try let's take a look at that. So we're gonna go here. We're gonna go ls. Okay, so here's a message. So if I were to just cat that out, um, it it's not. Oh wait, let me switch to a folder. Make this the present working directory. That's really messing with me more than it should be. Um, okay, it's a directory, so we'll change directory into that. Okay, so now we've got these .journal files, but the thing is, .journal is a file extension. It's compiled. It's a compiled file, so we're not going to see the source, like what's actually written in the file. We're just going to see that text that shows that it's compiled. So in order to actually read that, we need to go journal CTL, and then you can feed it a custom one. Let's do a help on it. And I should be able to feed it an actual see, I don't think I can feed it. I can't do like this. Yeah, because it's an invalid argument. So like, I'm not sure if I can feed it a specific. Oh, here we go. I can do -s file. There we go. And now I'm reading the journal file. You see I got some critically important debugging information that I might need access to. And you can't read it unless you use that command to, unless you run it through that command. All right, so that's it for this section. I want the guided exercises to be a part of its own video. So thanks for watching and stay tuned for the next one.